Hey everybody, hope you're doing well. Hope things are going okay. We are almost done this unit. We're on to applications of logarithmic functions. Okay, the applications of logarithms that we are going to use or to talk about, the big three that we're going to talk about are Richter scale, pH, and decibel. The reason why we talk about these and how they're related to logarithms is because we're talking about dealing with really, really, really big numbers. And when we're talking about really big numbers, we found it useful to put these things on a scale of 10, right? And so when we're talking about maybe an earthquake with a Richter scale of 10 to the power 8, that's a massive, massive number, which is almost too big for us to comprehend. So we say it's got a Richter number of 8. So we take these big numbers and we try to represent them with something that makes a little bit more sense. But what I want you to think about is we're dealing with really large numbers. So look at that. That 8 right there is an exponent. So if I've got an exponent, we're going to have to start dealing with logs because we're going to start trying to solve for these unknown exponents. Okay? Now, what's going to be important today is that you remember how to convert from an exponential to a logarithm. Okay, so that right there, again, my little expression is base stays the same, the other two parts switch. However, it's going to be always on your formula sheet, so if I ever forget, I'm just going to go and look at that. Okay, so let's go ahead, let's try a few of these, and we'll mostly in 30-2 just work with these three cases, but there are, again, more applications. Okay, so the magnitude of an earthquake is calculated using this formula here, or this equation. Okay, I'll never make you memorize those. Those will always be given to you. Okay, so M is the magnitude, I is the intensity. Okay, so magnitude we measure on the Richter scale. So I think we all know, so I'm saying the magnitude on the Richter scale, we go from 0, and we go actually all the way up to 10. I don't have it written there. Okay, so what I'm feeling right now is on the earth's not shaking underneath me. That's a magnitude of 0. Okay, so 10 to the exponent is 0. So nothing's really changing. Okay, all the way up to an earthquake of 10 to the power 10. That's going to cause some major destruction. Okay. So I'm going to just cruise through some of these notes right here where I just want to get straight to the question because I think you have all talked about earthquakes before. You have an understanding of the Richter scale as well. Okay, so let's look at example number 2 here. Okay, always lots of reading in these. Usually we're comparing two things together. So what does this guy say? It says we've got one earthquake measuring 7.6, had the aftershock, which is always weaker at 4.1. How many times more intense? Okay, so in the question, you always are given this formula. So what we're looking at here is two earthquakes. So I'm going to break this down as this. Earthquake 1, or just the earthquake, right, in this case. And I'm going to talk about the aftershock. Okay, well, when I'm stuck, I found it very useful over the years to just sub stuff into a formula, especially when I got it. So it says the earthquake originally had a magnitude of 7.6. And it said the aftershock had a magnitude of 4.1. Boom. Okay, now the question says, how many times more intense? Right there. Well, that means I'm looking for I, right? We're trying to figure out what I is. So if I look at my formulas, what I see is that there's my I. There's my I. My unknown is inside my logarithm. Okay, so if my unknown's inside my logarithm, I have to convert it to an exponential. So again, base stays the same. This is a common logarithm. So my base is 10, and the other two parts switch. There it is. Okay, I'm going to do the same thing for the aftershock. Okay, so now it says how many times more intense? Well, when I want to figure out how many times more intense, before I do this question with logarithms and earthquakes, let's just think about this. I've got $8 and you have $2. How many times more money do you have? You have 4 times more money than me. How I thought of that was 8 divided by 2, right? Times more intense. So I'm going to divide. And what I'm going to divide is always going to be the bigger divided by the smaller. Okay, let's go back and try this. Forget about dollar bills. Let's go back and talk about earthquakes. Well, times more intense. So I'm just going to write times more intense. Well, it's the bigger divided by the smaller. Well, the bigger one is 10 to the 7.6, and the smaller one was 10 to the 4.1. So guess what? I'm going to divide those things, and when I divide them, we subtract the exponents, and I get 10 to the 3.5, which I'm going to stick in my calculator, and I'm always going to have to tell you how to round, but worry about that later. This is about 3,162 times stronger. Okay, so a heck of a lot stronger. Now, that is what I would want to see for a written question. I'm going to show you a bit of a shortcut though. If this wasn't a written question, my friends, what we're going to do, if this wasn't a written question, you're going to go right to here. Right? 10 to the exponent of the bigger minus the smaller. That's your shortcut right there. Okay. Now that'll work here because we're keeping it simple. Okay. Later on, you know, when the math gets a little heavier in a different course, we won't always be able to go to the shortcut. But for now, if we had to, we could go to the shortcut. Okay, so keep that in mind. Multiple choice numeric response, probably want to save yourself some time. Okay, let's try a couple more. Okay, an earthquake in Cusco. Okay, so Cusco is where you first go to before you climb the Inca Trail in Peru. Going up to Machu Picchu, you should all try that. Okay, do it before they shut it down. It says it was 102 times more intense than an earthquake in Raleigh. Raleigh's in Thailand. It's beautiful. You should go there too. The magnitude of the earthquake in Cusco was 5.8. What's the magnitude of the earthquake in Raleigh? So here I'm looking for the magnitude, right? So again, if I'm stuck, I break this down into two things. Cusco, Raleigh. Okay. Again, what I've learned over the years is if I'm stuck on something and I've got a formula, which they will always give me, I find it very useful to sub in my numbers. It says the magnitude of Cusco was 5.8. Bang. My unknown is my intensity inside my logarithm, so I'm going to convert it to an exponential. Yeah. Hey, I'm going to do the same thing for Raleigh. Now, for Raleigh, they didn't tell me the magnitude. That's actually the question, isn't it? So I'm going to call it math's favorite letter X. And I'm just going to go through the motion here and convert it into intensity. Right? Okay, times more intense. I'm just going to use abbreviation here, TMI, right? Times more intense is equal to the bigger, well, the bigger one is what happened in Cusco, divided by the smaller one. That's what happened in Raleigh. But what we know this time is how many times intense it is. It says it's 102 times more intense. Now, again, I subtract these two things. I should say I'm dividing, so I subtract the exponents. Okay, but look at that. My unknown's my exponent. So if my unknown's an exponent, guess what you're going to have to do? Convert to a logarithm. So base stays the same. Notice the base is 10. I'm not even going to write it. Base stays the same. The other two parts switch. And now all we have to do is isolate for x. So remember, log 102 is just a number. In fact, it will be about, I don't know what it's going to be, about 2. I just rearrange, and now I'm just going to pick up my calculator. Notice how it's a common logarithm. They created these things to be common logarithms. So x is approximately 3.8. So there's your magnitude of the earthquake in Raleigh. Okay. So again, I've got a formula. I sub in my numbers and I start rearranging. Okay, so there's your 2 common earthquake questions. Nothing too crazy. Okay, we move on to pH. Now, pH is a little tricky because some of you haven't done science in a long, long time, whereas some of you are currently in science, right? So what, again, I need you to remember is pH goes from 0 to 14, 0 being very, very acidic, and 14 being very, very basic. Okay. Technically, acids are stronger than bases because they have more moles of hydronium ions up here, this H+. Okay. But if you see, when we're looking at this formula here, I want you to notice, here's your formula. And I remember when I was in science class, I learned, hey, just slam these buttons in your calculator to get the answer. Okay. See this negative right here? The reasons that's there, it's almost like when they made this scale, they almost got it backwards. It should almost be that, in my non-sciencey mind, that the bases should have a low pH. Okay, because you're going to see they almost had to put this negative in here to account for the fact that acids have more moles per liter of hydronium ions than bases. Okay, but you'll see what I'm talking about here as we go on to a question. And again, if I gave you a question like this, I would have to explain it to you, right, in the question, because I can't assume you remember any of this stuff from science class. If you've even taken it, right, that's the problem. Okay, so it says pH is a log scale of a base of 10. Yeah, we know that. There's my formula. Okay, so A, determine without a calculator. Yeah, maybe I'll use a calculator. The pH of a solution with the concentration of this many hydronium ions. Okay, so pH is equal to negative log of 10 to the negative 4. Now it says don't use a calculator, so I won't. And I'm just going to go sideways, even though that's bad math, but I'm writing big. Remember what we can do with an exponent. I can move it down out front and make it the coefficient. So that's going to become positive 4 log 10. And I'm hoping by now you're recognizing that log 10 is simply just 1. And so the pH of this thing is 4. Okay, a little too easy for us, but helps to see these things. Okay, next question, let's go pretty green. Next guy says we got a pH of 2. Let's find the hydronium ion. So I sub it into my formula. Okay, my unknown's inside my logarithm, so I'm going to have to convert to an exponential. First thing I'm going to do is divide both sides by negative 1. I'm going to get rid of that coefficient. Unknown's inside my logarithm, convert to an exponential. And there it is. Leave it just like that. Done. Easy peasy. Okay, now let's get into the question that probably 30-2 cares more about, comparing a couple of these things. So how much more acidic is a solution of pH of 1.6 than a solution of pH 2.5? Okay, on this one, I do the same thing I did before when I had the earthquakes. So here's my first pH, right? Again, when I'm stuck, what I know is I'm going to sub this information into my formula, divide both sides by the negative, and now, so I'm just running out of room here, so I'm going to go up here, going to convert it to an exponential. So that's my hydronium concentration for the first solution. Okay. The second solution, I'm going to do the exact same thing, and I'm just going to cut right to the chase. If I had more room, I would show all my work, but here's my second one. Okay, so now, how many times more acidic? Same as the times more intense question. So times more acidic, again, I'm only using abbreviation because I'm low on room. Well, it's the bigger minus the smaller. Now, the bigger number is actually this guy. Okay, it's closer to 0 than the other one. So that's actually the bigger. There's the smaller. Now, what happens here, this is where that negative comes into play that I was talking about earlier. Okay, what happens here is when we subtract, I'm going to subtract that negative, but we all know what happens when we subtract a negative. It's going to become a positive. So I'm just going to rewrite that like that. And so look at, there's our shortcut again, 10 to the power of the bigger minus the smaller. And that's that. And so, I mean, this thing is going to be just a little bit smaller than 10. It's approximately 7.9 times stronger. Okay. Number 5, it's pretty much the same thing as the earthquake question. So this one's saying, I know one of the intensities, and or I know how many times more intense, and I know the pH of one of the solutions. Okay, so again, I got my formula. When I'm stuck, I sub in numbers. So pH negative log of those hydronium ions, sub in my 7. Divide by the negative 1. And convert it to an exponential. Okay. Now, there's another solution, solution 2, so it's the same thing, right? It's some other solution, but this one I don't know what my pH is. So this one I'm just going to skip a few steps. I'm just going to call it a pH of X, right? I don't know what it is. Okay, so now I'm going to put these things together because it says times more intense. How many times stronger, times more acidic? So times more acidic is the bigger minus or divided by the smaller. Okay, so the pH of pure water is 7. What is the pH of a solution that's 50 times more acidic than water? So the acidic one, it's 50 times more acidic. This guy is going to be the stronger one, the bigger one, and this one's going to be the smaller one. So now I know that we're 50 times stronger. I subtract these things, and remember, when I'm subtracting, that one's going to become, the negative 7 is going to become positive, because a minus and a minus give us a positive. Unknowns in my exponent, convert that bad boy to a logarithm. Again, it's a common log, so I don't feel the need to write the base, but I sure could. But I'm lazy, so I'm not going to. And convert. And I'm going to stick this thing in my calculator. Again, it's convenient that it's a common log. That's why they made it that way. And so I get x is approximately, has a pH of 5.3, which makes sense. It's smaller than 7, right? Because it's more acidic. It's got to be lower on the pH scale. Okay, last one we need to look at, and then we are good to go, is the good old decibel question. Okay, now decibels aren't too much different than these. You're always going to be given this formula right here. But do you see on this one, there's a 10. Well, the word decibel, deci, means 10, right? So they factored this 10 into the formula because think of sounds. I could drop a pin, or I could be a rocket taken off to the moon. There's a big variation. So that's why they've got that 10 in there. Okay, so let's just try, I think, one of these. I think we'll just do number 6, and then I think we've probably got the point. Okay, here's a telephone dial, which there was a day when we called each other all the time instead of texting. And there's ordinary conversation. So again, I'm stuck. I don't know what I'm doing, but my teacher gave me a formula. Let's use it. Oops, I missed my 10. Let's use it. Right. So my telephone dial has a decibel of 80. I'm going to divide both sides by 10. And I want to know how many times louder. So guess what? That's my unknown right there. So I'm going to convert this to an exponential. Okay? Do the same thing for ordinary conversation. So I'm going to just, again, skip a few steps. I think you've got that figured out by now. You know, again, if that was a written test, I probably wouldn't do that. Okay? So now, how many times louder? Let's find, what's a pretty color? Oh, there's black. I've never used black. Okay, so times louder. Well, it's the bigger divided by the smaller. 8 minus 5 is 3. And holy mucho burrito, it is 1,000 times louder. There it is. Okay, the next question is the exact same, right? Are you starting to notice a pattern here? That there's only a couple types of questions that I can ask you in here, right? Or at least, I shouldn't say, there's only a couple I can ask you. There's only a couple I'm going to ask you to keep it simple. Okay, because we're just learning this. Okay, so this one, how many times louder is this compared to the whisper? Okay, now I'm going to cheat. I'm going to pretend this is multiple choice or numeric response. I'm going to go right to my shortcut. Times louder is equal to 10 to the bigger on my scale minus the smaller on my scale. Well, if this was a decibel, I would divide that by 10. So that would be 9.8 on my scale. And I'm going to divide this guy by 10. That's going to be 2 on my scale. Now, if you go and put that in your calculator, you're going to get a ginormous number. Okay, whatever the heck that is, it's huge. I think I'm just going to leave it like that. It's 10 to the exponent of 7.8 times louder. Holy cow, big time. So when you're doing these questions, my friends, no need to memorize a formula. As you can see, the biggest part here is really, can I switch from an exponent to a log? Can I switch from an exponent to a log? That's it. If you understand how to do that, you should be hopefully in good shape. Okay, I hope you're all doing well. We're almost done this unit, and then we'll be on to the next. Okay, everybody. Take care. See you next time.